In this question, I want to talk about another way that we can eliminate repetition. We can write queries that compose multiple operations. I want to talk about another thing that we could call a variable in SQL. I want to talk about common table expressions. What are common table expressions and how do they differ from other approaches? And if we go back to our fundamental thinking, everything starts in the same place. We start with the tuple space with these individual tuples. Each one of these we'd call a row. Each one of the 0, 1, 2 we'd call a column. What we're doing in any computation is we're starting from a tuple space that looks like this on the left-hand side and turning into a tuple space that looks like this on the right-hand side. And we need to figure out how each of these x and y's correspond to a, b, c, and d, how the zeros and the ones on the left-hand side correspond to the zeros and ones on the right-hand side, what the transformation is. If it's the case that this is multi-step, then we can think that we need some way to take this partial output and feed it into this partial output to get this partial output. The shape of this operation, if x is a combination of some non-overlapping partition of this data, like just a and b, and y is some combination of c and d, that's a group by. If this is some filtering, give me something that's just a and just c, then that's like a where clause. Or if it's, some grouping where we've then filtered the grouping, that's a having clause. If it's something where we've done where these operations that we performed are a consequence of a filtering and then something that's on a window, that might be a window function. Well, setting all of those aside, let's talk about how we might do this operation of piping the data between the different parts. Because we've seen other variable equivalents, temporary tables, we've seen subqueries. Let's talk about common table expressions. If I have my data and I want to figure out what is the name for each one of these rows, for each one of the categories with the maximum value per category. So that would be A1, B2, and I guess these are all kind of, so this would be B2 for category X, C3 for category Y, and E and D for category Z. Well, I know I can do that with a subquery. And I know it looks something like this. Here, I can do a self-join that gives me the ability to compare two things at the same time. I can have it compare both the original data and what the max is. So basically, I supplemented each one of these rows with information about the max, and then I can compare, are you the max or not? If I find that this doesn't compose very well, because you can see this gets really messy really quickly, I can express almost the same idea, but just very slightly differently by first pre-computing this result, and instead of putting it into a temporary table, expressing it as a common table expression. All a common table expression is the idea of like putting something into a temporary table that you're going to use, but you're going to use it immediately, and you don't want to create a temporary table because you want this thing to be computed as part of the current SQL statement. So this is another way that I can accomplish the exact same task. It is the case that when I perform these common table expressions, they correspond to some ordered set of operations. So this is probably the closest analog to a variable that we've seen so far, because we often see something like x equals 1, y equals x plus 1, z equals y plus 1, and we get exactly that behavior from these common table expressions. Here we'll do multiply times 2, and we'll see each step along the way, that's what the x's were, that's what the y's are, and this is what the z's are. We can perform subsequent operations almost like a procedural language. And these are ordered so that if we swap the order of these, we get an error. It is very much the case that this runs first, this runs next, and this runs last, which is why we might not want to use common table expressions, because you can think it's forcing this query to be run, it's forcing this query to be run, and it's forcing this query to be run. And if the query engine has some way to merge these together or to use some sort of predicate pushdown to filter the total amount of data that we want to look at, we are going to prevent it from applying that, because historically CTEs have presented at optimization barriers and subqueries have not. And so even though this is yet another way we can perform something kind of similar to what we did with the subquery, we might choose the subquery over this approach if, for example, we want the SQL engine to be able to optimize this, or we might choose this approach over the subquery if it's the case that we want the code to be a little bit more procedural, and we want it to really look like something like a variable where you set something and then you can reuse something. With the subquery, we often find that we may need to cut and paste that same subquery in multiple parts, whereas with the CTE, this gives us that variable analog of compute the operation once, store it somewhere, and use it in multiple places. But I want to show you something really neat that you can do with CTEs that you cannot do with anything else. Let's say for my data, it's not one table with the category and the facet as inline data in the table. It is multiple tables, and there are references between these. And I want to insert into this table. I want to insert the category name, then insert the facet name, and then insert the data referencing the category name and the facet name. When I do this, I get an error because I need to know what the ID is, return from this. I need to know what the ID is, return from this. And it turns out that those IDs are starting at 1. Okay, now I get what I expect to get. But how do I know that the ID for this category that joins to this table here and the ID for this facet that joins to this table here is 1? I don't, because I just inserted these. So what I would do in a programming language is I'd say return value 0 equals this, return value 1 equals this, return value 1 and return value 0, basic use of variables. But since I don't have variables in SQL, I have to figure out a way to do this. Now, I don't want to do this with a temporary table because that would be very clumsy. I could do this with a subquery maybe, but I don't think I can put an insert into a subquery. But I can put data modification statements into common table expressions. So what I could do is I could do a common table expression performing one insert and returning an ID, performing another insert and returning an ID, and then performing the third insert referring to the previous steps. This is a very close analog to our idea of a variable. And I could write this up as a simple temporary function. One thing that you'll note is there's a subtle and really tricky thing to fix. This only will work if I'm inserting the category and the facet and it doesn't already exist. If it already exists, then I have to make this much more complicated. But I'll leave that for you to think about. And hopefully as we go deeper into this, you're beginning to see what is possible and what is not possible with SQL based on how you think about SQL.